Hi, my name is Abraham Campbell, and today I'm presenting a video on reflecting and evaluating the use of augmented reality for technological enabled learning of computer graphics. And to do that, I'm going to first explain what augmented reality is, sort of a short history of its development, and the sort of a history of virtual environments that relates to computer graphics, the current uses in teaching, with a very short little demo just to give you an idea of how those aspects work, an applied demonstration where I'll actually show how I would use this in a computer graphics class, and then finally reflection on the benefits and the difficulties of using augmented reality as a learning aid in the future. So to start off, what is mixed reality? Well, if you can imagine your real world, it is just the real world on its own. There is no 3D graphics or anything in front of you, it is just the real world. But if we're able to add a little virtual component, a little thing floating in front of you, let's say you're wearing special glasses to see this, a little sphere that you're going to see in a second, that starts into an augmented reality environment. As we keep adding more and more virtual components in, we get an augmented virtuality. And finally, if there was no real world components left, we were just wearing a 3D headset, we would just see a virtual environment. And this taxonomy got built in 1994 by Milgram and Cashismo to really give us an idea and a language to describe what this concept of actually bringing 3D graphics into our everyday world. But first, let's kind of think about where virtual environments sort of came from the beginning. In 1900, there was the Cinerama project, which was presented in the Paris exhibition, which simulated an actual balloon ride. It used multiple projectors, as you can see below in the image, to present a balloon ride over Paris. Of course, this would be black and white, but in its day it was very impressive. Most participants who saw it actually said they actually experienced sort of motion sickness and were amazed by the movement. But it wasn't for another 50 years till this sort of thing became sort of a mainstream that you could have a virtual environment. And the reason for this is just a technology one. One of the difficulties was literally the projectors, as they were placed in the bottom, would overheat, and fire marshals were worried of a fire risk. In fact, back then you would have had a silver screen, so potentially the whole thing could have gone up in flames, and literally the environment itself actually was so hot it could actually nearly take off as just a balloon as it is. So it wasn't until sort of the late 50s that we had a sensorama, this idea of a virtual environment where you could sit down and look in, and this was developed by Morten Helgel. But again, there wasn't that enough content to really be that successful. Hegel had tried to also patent it and tried to make kind of money off it. Really, the technology wasn't advanced enough, because what it really needed was actual computer graphics. And that wasn't really developed until 1964, the sort of first computer graphics by Evan Sutherland. This is the Sketchpad program. Very simple program that you would just use to sort of design sort of shapes, and people who are familiar with CAD or Photoshop wouldn't be unfamiliar with how the first Sketchpad worked. And it showed us these sort of very basic vector graphics. And in fact, Ivan Sutherland in his postdoc work actually developed the first headset. The first sort of, and it was actually an augmented reality headset, because he could place a sort of small vector cube in front of his eyes that would be floating in front. And of course this became known as the Sword of Damocles machine, because obviously you can see above his head was quite a lot of metal rods and so forth to support the weight of this headset, which essentially was 2 TV tubes going directly into his eyes. But the sort of modern day augmented reality headsets, and nowadays we're more used to seeing augmented reality in webcams, which I'll discuss later, came actually from Boeing in 1992, where we have Claude and Michel's sort of first sort of patent on an augmented reality headset. The idea that you would have beam splitters at the very top that you'd be able to see in the real world, and also the same size see a virtual display from a screen. Essentially this would be accomplished by sort of a halfway, half-silvered mirror where you can see through it, but also see sort of virtual objects. And nowadays we're sort of more used to sort of webcams, and one of the first sort of displays was a 3D headset, and our toolkit, pretty much a lot, if you have experienced augmented reality, a lot of it derives from the sort of technology that was invented by Kato and Billinghurst in our toolkit in 1999. And nowadays, we can just simply use our sort of mobile phones to use augmented reality content, and here's some of the most common example, which would be layer. So you'd see sort of a dot in the distance, and you'd see through the camera based on your mobile phone. And of course, in the future, we'd like these to actually be in contact lenses. And this is sort of research by Lingley et al. That actually shows that you could put a display right on a contact lens. And they've tested it on, obviously, rabbits to make sure that for humans this will be safe to do. But what's really important and what this video is about is examples of AR being used as a learning aid. And here we can see sort of an Earth. This is based on Liu et al.'s work, that you could actually have, let's say, an Earth floating in front of a school kid, and you could see the different areas of the mantle there broken down into separate components. And other work, such as Gibro, has also shown how successful some of these sort of aspects of learning aid. But in general, any of these sort of experiments have pretty much shown that you could use physical models, but this is a more advanced model. And if we start thinking back to sort of our learning theories and Gardner's spatial intelligence, the idea that we could actually have physically presented in front of a student an augmented reality object where they could actually explore, and finally they could really construct their own learning experience. They could actually see how this model interacts with different models and sort of build up a sort of a way of doing this. And that's exactly what we're going to show you now. Very quick demo of sort of a solar system, just concentrating on Earth itself and just showing a basic rotation for Earth. So, when you next see me, I'll be in the lab. Hi, welcome to the lab. And let's just show you kind of a more visual example of what some of these learning aids actually look like. So, we have a very, very basic demo here. It's based on sort of our toolkit that we discussed before, and using a Java implementation by Geiger and et al. And I've modified the program a little bit just to demonstrate some computer graphics later on, but this just is to give you an idea that we have a marker here where we placed a bit of 3D graphics that I can see through the webcam here. You can see I can interact a little bit by rotating this around, and if I kind of match the rotation with actually, can I match the rotation? I can a little bit. It gives me the idea of that the Earth is spinning around there. So this is just to give you an idea of those sort of learning aids that we're discussing, how people are using this, is they're putting a 3D object and putting it in space where a student can actually physically move it around. Okay, so the next bit, I'm going to show how I could actually use this to sort of teach some computer graphics. So, what we now want to see is, can we demonstrate an augmented reality lesson in computer graphics and show how we can really have that sort of constructivist sort of experience using these sort of models to allow our students to sort of interact instead of just us kind of saying how this sort of interaction should take place. We're trying to construct that environment, and one theorist did kind of describe this as kind of creating a virtual community with the lecturer just performing that role of constructing environment and developing it to begin with. So, back to the lab. Back to the lab. And now what I want to do is take that quick little demo I showed you there and show I've got a little bit more functionality in it and show how I would use it to teach some concepts in computer science, in particular in terms of computer graphics. So we can take our little mobile camera out and we get that right angle there, and we can see a picture again of our globe here. But what we're going to do in this case is we're now going to change that globe just to be a solid object. So there's not going to be any textures on it. So it's a concept of computer science that when you have a 3D object, you can actually put a texture on it to actually make it more detailed and essentially show, as you can imagine, the sort of textures that you would have on objects. So what we're going to do is, with this object, we're going to light it. course, this second marker that has AB written on it is actually going to be a light source. At first, we're using a concept of ambient light. So essentially, the AB light source there is just engulfing the object in sort of light, the way, if you could imagine, multiple light sources would light an object. But what we can turn is change that into more of a sort of a torchlight. And so what we're now seeing here is it's acting more of a torchlight. And I've set up this object to really be kind of simulating a little metallic ball. So we can see this from a few different angles. And you can see here how the light, of course, changes depending on the angle that we're seeing it from. But what we can also do is convert this light into a point light, similar to the light you'd be used to in sort of a bulb. So to give you that idea, if I keep it, and it's now currently a torchlight, you can see it's not reflecting any more off that wall there. Okay, make sure I got that at the right angle. But if I convert it into a point light like a bulb, even though if I change the direction of the light, nothing happens, it'll still shine on that ball. But let's go back to our directional light to show you the difference. Try and keep all of these in the same idea. As you can see here, if the AB is pointed at the ball, we can see the light. As it turns away, you can see that it's acting like a torchlight. So the difference here is a point light source is just going to show out that light in every direction, like a bulb. And if I move it away, so to do that, kind of get a bit of an angle. If I bring it closer, you'll see the light is even brighter. And let's say we move that away a bit there. It'll dissipate a little bit on that. But if I go back to the torchlight, we won't see anything unless it's pointing straight at it. Now also you can see that white dot that exists on that sphere. And that white dot is because we're simulating it being a metallic object. So what I can do is actually turn off the metallic object. And now you're not going to see that light. Because what's happening is the reflections are coming straight in here and are being diffuse, bouncing any way off it. But if that was a metallic object, what would be happening is certain reflections would be bouncing and they'd be going straight towards the camera. And of course, this is the camera here that we're seeing. So students could use this as a learning aid to actually explore how different objects, different materials, and different light sources actually reflect. So this is something I haven't actually seen any computer science literature do, and it's one of my sort of many areas of research. So I think this could be a fascinating way of actually teaching computer science. And of course, we can go back to our nice little sphere here. And of course, it looks a lot better when it's being lit this way. Let's go back to a sort of a nice point light source here. And in fact, you'll notice this looks kind of like what you actually are used to seeing from sort of spaceships and so forth. Now, you wouldn't get that bright light going over the Earth because the Earth is sort of diffused. But going over the water, you will get that sort of specular light where the light will actually reflect perfectly in whatever angle it's being gone at. So, I'm trying to get all of these in the same frame here, just to give you an idea there of the Earth there. So, this has just been a very short applied demo of how you can actually use this as a teaching aid. And we'll go back to the slides there and we'll discuss some of the benefits and some of the difficulties, and some of them are pretty obvious of, as you can see me trying to get all the camera angles right and showing everything there. So now that I've shown you sort of an AR lesson, albeit a very, very quick one, of how we could actually start using augmented reality to teach computer graphics, to go into a little bit more detail about why, the sort of benefits and difficulties. But first, obviously, what I've just done there, I was using a lot of technology that I've used over the years for different research projects, R Toolkit, Jar Toolkit. For most people, obviously, these tools, you would actually require a good bit of computer knowledge, and especially the ability to add in that flashlight and so forth. And Light the Object actually was a startup company back in 2000, so it is quite a difficult task sometimes to do. So if you want to do it yourself, there is the program called Atomic. it's augmented reality and mind mapping authoring tool. And you won't be able to do some of the stuff I was doing with lights there, but in terms of objects, no problem getting them sort of segmented. So this is just a list of the URL to get access for them. And if you're looking for sort of more blogs about augmented reality, Games Al Fresco is absolutely the best blog. And I'm going to be putting this video up, and a lot of my sort of common thoughts about what the possibilities for augmented reality is we are on a website called wearealldruidsnow.com. But let's discuss some of the sort of benefits and sort of the difficulties that we experienced there. So it is a new way of using computers, and you could imagine the future if we actually all had our nice little contact lenses, we could display all of our computer information just floating in front of us. So the benefits obviously are immense and sort of impossible in a short video to discuss, but that sort of visual feedback that we can get, the constructive learning that we could actually generate, and especially if you by your nature are a spatial learner, which I certainly am, this could be an amazing way of actually being able to interact with the content that we're learning. And if you generate models, you can actually get those models to interact to aid in that. And of course, there's an immense amount of difficulties there. Even in the short demo that I showed you today using current technology, we have the problem that most people's webcams are integrated into their laptops, so they're fixed. You can't just simply move them around as I did there. And in terms of the lecturer, even that little demo that you saw me there took a couple of hours just to get out a couple of bugs to make sure it would work. So obviously authoring tools are in development, and there's a good few more to come to actually be allowing us to use this. And of course, at the moment, we need these sort of physical markers. Now, of course, anybody's familiar with the Kinect technology is being developed to allow us to interact with sort of augmented reality just by putting our hands up in the air and interacting that way. And not only is the Kinect there, but there's a lot of research in that sort of area of technology, and I might put up in the forums some sort of the new ways of sort of interacting directly with computers and that. So this was just a very, very short, about 20 minutes, but it's the start of a massive sort of discussion that I'm hopefully going to be having in We Are All Druids Now, just to show some of AR's possibilities. And just for your own information, if any of the topics seem interesting, this is just a short reference list to everything we discussed. And as I'm also doing this video for my postgrad diploma in education, here's obviously for my graders, my student Abraham Campbell, and obviously my student number. So thank you for spending the time watching this video, and I hope it was informative.